Hi everyone, this is Dr. Swaminathan SM, Associate Professor, EC Department, SNS College of Technology. Now I am going to discuss about the topic called Impulse and Step Response Analysis of the Second Order System. So last class we discussed about the same different damping ratio for the step and impulse response for the second order system, and today we now discuss about the topic second order system, time domain specification, transient response analysis, rise time, peak time, percentage overshoot of the setting time, and activity. So next, the activity, after activity, the underdamped examples and the overdamped response and step response of the second order system summary we will discuss next video. So the second order system, it exhibits a wide range of the response. It must be analyzed and described for the first order system, that is varying with the single parameter changes, the speed response and change in the parameter of the second order system. It can change the form of examples, different examples. So first, the second order system can display the characteristics much like first order system, or depending on the component values it must be displayed damped or pure oscillations for its transient response. So the second order system, it must be having the value of the denominator square, that is s squared plus as plus b, and the numerator value, that is called b. Then you can get to rewrite the examples, that is omega n square divided by s square plus 2 sigma omega ns plus omega n square. So next, the second order system, the omega n is equal to root b, that is undamped natural frequency, and a divided by 2 root b, that must be called damping ratio. So you can get the different poles, minus omega n tau plus or minus omega n omega root of omega squared, that is minus 1. So these poles are complex conjugate when tau is equal to, that is tau less than 1. And already we discussed about the different ratios, that is over damped greater than 1, under damped means that is under the value between zeros and 1, undamped means equal to 0, critically damped means equal to 1. So the time domain specified, that is omega n square divided by s square plus 2 sigma omega ns plus omega n square, that is the times domain specification. So here the look at this graph, you can get this transient response. Transient means we already discussed, with respect to time the output is varied, that is called a transient response. Steady state means the output is not varied, that is called steady state. So this is the transient response and this is a steady state response. Next to the 4 transient specifications, that is rise time, peak time, percentage overshoot, and setting time, that is 20% of error. You can get this transient response different specifications. So transient response means rise time. Rise time means pi minus 6 divided by omega n root of 1 minus tau square. And same thing for peak time, pi divided by omega n root of 1 minus sigma square. And the percentage maximum overshoot, you can get this percentage means multiplied by 100%. So steady state response. So steady state error we will discuss next class. But the question is, how are the performance related to tau and omega n? So these are all the examples. So C of s is equal to R of s into G of s. So you can get the value of omega n squared in terms of s domain. So C of t, we just apply the inverse Laplace transform to get the C of t from C of s. So theta is equal to tan inverse root of 1 minus tau square divided by tau. So these are all the second order system, C of s divided by R of s. So you can get the theta value, tan inverse root of 1 minus sigma square divided by sigma. And rewrite this example, you can get the beta and omega d value for these examples. And C of t, you can get the 1 minus beta, 1 divided by beta, e power minus sigma omega n t, sine of omega dt plus tau. So these are all the transient response. So y is equal to, that is first one not equal to 0 and second one equal to 0. So you can get the value of tt, transient response, rise time. And the peak time, that is you can get the peak time value, C of t is equal to 0. Then you can get the peak time response. And the percentage overshoot, you can get the C of Tp minus C of infinite divided by C of infinite into 100%. That is C max minus C final divided by C final into 100. So you can get the value Tp is equal to pi by omega d, pi divided by omega n root of 1 minus sigma squared. So you can get the value sin theta is equal to root of 1 minus dou squared. So the following with the activity we will discuss about the next class, that is percentage of overshoot. Thank you.